Hello, beautiful people. Today we have task number 3, which is a practical exercise from the digital forensics section. This is a really awesome exercise. This type of exercise is the exercise that you could show anyone that's, let's say, not familiar with cybersecurity and can instantly enjoy it. Okay, let's go. Everything we do on our digital devices, from smartphones to computers, leaves traces. Let's see how we can use this in the subsequent investigation. We have to download some files from here. I already downloaded them. As you can see, if we list the contents of this file, we have this random letter to zip. In order to unzip it, just use unzip. As you can see here, the command unzip ransom, and this will bring us with 3 files. We have an image, we have a doc file, and we have a PDF file. Let's move on. Our cat, Gado, has been kidnapped. The kidnapper has sent us a document with their requests in MS Word document format. We have converted the document to PDF format and extract the image from the Microsoft Word file for your convenience. Okay. You can download the attached file to your local machine for inspection. However, for your convenience, we have added the files to the attack box. I just downloaded them in our Linux machine. To follow along, open the terminal on the attack box, then go to the directory root rooms intro to digital forensics as shown below. In the following terminal output, we change to the directory containing the case files. Here we can see the same files, 3 files, the image, the doc file, and the PDF, as long as they zip file or archive. Document metadata. These are, you read over here, that everything we do on our digital devices, from smartphones to computers, leave traces. Metadata is also an important data to watch. When you create a text file, txt, some metadata gets saved by the operating system, such as file creation date and last modification date. However, much information gets kept within the file's metadata when you use a more advanced editor, such as MS Word. There are various ways to read the file metadata. You might open them within their official viewer or editor, or use a suitable forensics tool. Note that exporting the file to other formats such as PDF would maintain most of the metadata of the original document, depending on the PDF writer used. Let's see what we can learn from the PDF file. We can try to read the metadata using the program PDF Info. PDF Info displays various metadata related to a PDF file, such as titles, subjects, authors, creator, and creation date. The attack box already has PDF Info installed. However, if you are using Kali Linux, which we do, and don't have PDF Info installed, you can install it using sudo apt install poplar utils. Consider the following example of using PDF Info document.pdf. Here is just an example of how to use a PDF Info, and we have to use the command in order to install the tools that we need. So let's just copy these. Let's just jump into our terminal and let's go. The password for your machine, and you wait for it to successfully install. Until then, we can see here the command used on a document, and here we can see the metadata that we talked about plus some more. You can also see the pages that the document has, if the JavaScript, if there is written some JavaScript, forms, suspects, user properties, page size. Pretty cool. Even PDF version that is that was written in. The PDF metadata clearly shows that it was created using MS Word for Office 365 on October 10th, 2018. As you can see, exactly that information. And let's check our installation. All right, and now let's say, all right, and say ransom letter PDF. Look at this. We can see title, pay now, Jesus. Subject, we have Gato. We see author, the creation date. We can clearly see Wednesday, 23 February 2022 at 11:10. So we can see all kind of metadata. Answer the questions below. Using PDF info, find out the author of the attached PDF file. We already saw the author right over here, Anne Gree Shepherd. Here we see another tool used for photos. EXIF stands for Exchangeable Image File Format. It is a standard for saving metadata to image files. So it's the same kind of application used for metadata inside pictures. Whenever you take a photo with your smartphone or with your digital camera, plenty of the information gets embedded in the image. So like we read before, for the previous file, that was a Microsoft document, the operating system saves metadata on that automatically in the background when you create the file. So this is done by Android or iOS when you do a picture. The following are examples of metadata that can be found in the original digital images: camera model, smartphone model, date and time of the image captured, photo settings as focal length, aperture, shutter speed, and ISO speed, and ISO settings. Because smartphones are equipped with a GPS sensor, finding GPS coordinates embedded in the image is highly probable. The GPS coordinates, that is latitude and longitude, would generally show the place where the photo was taken. Actually, it will show the pinpoint location where the photo was taken. There are many online and offline tools to read the EXIF data from images. One command line tool is EXIF tool. EXIF tool is used to read and write metadata in various file types, such as JPEG images. The attack box already has EXIF tool installed. However, if you are using Kali Linux, which we do, and don't have EXIF tool installed, you can install it using sudo apt install libimage EXIF tool perl. Yes, we'll use this command. In the following terminal window, we execute EXIF tool. As you can see, it's used exactly like PDF info. You just use the name of the tool and then you use the file that you want to check out the metadata. We executed EXIF tool on image.jpg to read all the EXIF data embedded in this image. Here you can see the usage of that, and only it shows the GPS position. If you take the above coordinates and search one of the online maps, you will learn more about this location. Searching Microsoft Bing Maps or Google Maps for 5. Actually, let's go and search it. Let's go here. Let's paste it here and let's say search. Actually, it found nothing. All right, let's search for this. Actually, I think it's the same. All right, I will paste it in the search box above. Let's see here. All right, nothing. All right, I'll stay in here. I'll stay in Google Maps. And let me see. We have to change degrees with that specific symbol. Let's paste this. Actually, let's paste this and say search. All right, there we go. In London, you have the pinpoint location where that photo was taken. Pretty cool. All right. If we read here, it will say that you have to change the symbols. Reveals the street where the photo was taken. Know that for the search to work, we have to replace degrees with the symbol and remove the extra white space. In other words, we have the coordinates that we use to see the correct location. In the map search bar, using EXIF tool or any similar tool, try to find where the kidnappers took the image they attached to their document. What is the name of the street? Okay, let's go. So we'll say EXIF tool. Let me see what files we have in there. Letter image.jpg. Here we have the GPS coordinates where the photo was taken. It was lens was a Canon 50 millimeters. We gave a depth of field, circle of confusion, focal length, a lot of information. Latitude and longitude. Actually, we have to copy these both. Copy selection, and let's place it here. We'll place it here. I'll go back, copy this symbol, and then do it manually. North 0 degrees west. We should have a result now. I see the same location. I see the exact same location. The name of the street. Let's remove that. Let's search again. Okay, let's check again. 50 degrees, 30. These are also symbols for minutes and seconds. 50 degrees, 30, 51.90 north, 0 degrees, 5. Actually, we have to take that out. 5, 38.73 west. Okay, Milk Street. All right, so it's the same location. What is the model name of the camera used to take this photo? I mean, we saw that it's a Canon. We saw the lens, but let me see. Oh my God, so much data. You have a ton of data with this image. Here you can see the lens profile. Again, the lens. Wait, you have even you even have a flag. Canon. Here we go. Here we go. Canon EOS R6. Boom. Awesome.